Hey guys, what I have here is a drawing that I've constrained so that I can move this circle, which we'll call a sphere. I can move it back and forth, closer and further from a fixed origin in an XY plane. And this will allow me to practice and verify the results of a well-known astronomy equation called the small angle formula. And so this formula says that for three unknown values, if we have two, actually let me start over. For three values, this formula allows us to find any one unknown value if the other two values are known. This equation relates the angular diameter of an object to its distance and its true diameter. And so let's just change the size of this circle and the position of the circle so we can start from some fresh unknowns. Then we'll find two, and then we'll leave the third as unknown. Alright, so we go here, we can unfix this. Delete, move it up a little, change the size of the circle, and then we'll refix it, and we're done. Alright, now let's move the circle to some arbitrary distance. Actually, let me start over. Move it to right there. Alright, and now let's find the angle that's formed between this line and this line. This is called the angular diameter of this object and the distance to the object. So we use our smart dimension. Distance. Alright, so the distance is 8.3 units, and the angle is 21.01 units. And so we'll leave the size of this circle as an unknown that we'll find with the formula. And so the formula, if you look at it here, says that the linear distance from here, the top of this sphere, we'll call it a sphere, to the bottom of the sphere, is equal to the angle times the distance from a viewer that the object is over a constant that I won't explain here that's 206,265. And so with that information, let's proceed. We'll whip out our TI-84 emulator and plug in these values. So let me move it up a little bit. So so it's going to be this times this. Oh, I almost forgot that we need, because we're using units of arc seconds, we need to convert 21.01 to arc seconds. And the way we do this is we come over here and we get rid of these values. Alright, 21.01 convert. So these are the units we're actually going to be using, and the value for that is 75,636. 75,636. Turn this on. Clear. 75636. 636. And then go back to our drawing. Times 8.3. 8.3 divided by the constant, which we have here is, move this over, is 206265. 206265. Enter. Okay, this says that the diameter of our sphere, our circle, the linear size of the sphere, is 3.04 units approximately. It's going to be a little off because we're not using enough significant digits, but that's fine. It'll be close enough so we can verify that the formula worked. So let's go ahead and measure the diameter of this circle and see if we're right. So 3.03. Go back to the calculator. 3.04 is close enough. And if we use more significant digits in our setup, then we would have gotten a much better measurement. So now Okay, so I'm going to do another video where I've changed the size of the circle, and then we'll find a different unknown besides this one. Okay, so stay tuned.